In a previous video, we talked about the two different columns on a pressure temperature chart for some refrigerants. That you have a liquid pressure and a vapor pressure chart, and we discussed the difference between the bubble point and the dew point. In this video, we're going to explain further the glide of different refrigerants. So on this slide, we're using our Danfoss refrigerant slider that we introduced to you in a number of videos. And we recommend that you download this on your phone or tablet so you have all the refrigerants that we work with at your fingertips on your phone or tablet. In this particular case, we are looking at R22. And you'll notice that it only has one point, and it is a single component refrigerant. So it's 75 psig. Our temperature is going to be 44.31, and that will be our temperature throughout our coil. So here we see a visual of R22 moving through an evaporator coil, and at 75 pounds, our coil temperature is going to be 44.2. This is because R22 is an azeotropic mixture, which means that it is a single component refrigerant. So entering the coil, it's going to be 44.2 degrees, and when it exits the coil, it's going to be 44.2 degrees. Now, of course, you take into consideration that the latter part of the coil, we're going to start adding superheat, and of course, so that temperature will increase at that point in the coil. So we were running those numbers on an R22, which is a single component refrigerant. Let's now look at R454B, which is the refrigerant that a lot of major manufacturers will be moving to in the next year or so. R454B is called a near zeotropic mixture. Zeotropic means that it's two or more components with different boiling points. A near zeotropic mixture is where you have two or more components with different boiling points, but they act like a single component refrigerant. So on this slide, with our refrigerant slider, we're looking at the 454B refrigerant, and you'll notice that you have a bubble point, which at 100 pounds psig, our temperature is 34.26. And then you have a dew point, which at our pressure of 100 psig, our temperature is 36.59. So you see that between our bubble point and dew point, we have 34.26 degrees for our bubble point and 36.59 for our dew point. So keep in mind when we're talking about bubble and dew point that you remember the chart where we talked about 32-degree liquid, and we heat it up and it becomes 212 degrees liquid. And then we continue with latent heat that turns the liquid into a vapor, and it's still 212 degrees. This is what we're talking about with a single component refrigerant, and that there is no glide on a single component refrigerant. The bubble point and the dew point are the same at 212 degrees. The temperature and pressure does not change. So keep this in mind as we're looking at these different refrigerants and the glide or the difference in the temperature. So on this slide, we see a visual of R454B as it moves through the evaporator. As we saw on our slider a moment ago, our entering temperature at 100 pounds is 34.26 degrees. Our exiting refrigerant temperature at 100 pounds is 36.59. To find our glide, we take 36.59, subtract 34.26 from it to get 2.33, and we divide that by 2, which gives us a 1.165 glide. This also gives us a midpoint temperature of our coil of 35.42. This is why we call R454B a near azeotropic mixture, because it acts like a single component refrigerant with only a 1.165 glide ratio. So let's take a look at a refrigerant that has a larger glide. R401B has a pretty large temperature glide, and so therefore it is definitely a zeotropic mixture. You'll notice on the slider that 401B has a dew point, and at 100 pounds, the temperature of the coil will be 82.69, and at the bubble point, at 100 pounds, our temperature would be 74.45. So when we put R401B on a visual, we see that our bubble temperature of 74.45 entering and our dew point of 82.69 exiting the coil. So we subtract those two and we get 8.24, which divided by 2 gives us a glide of 4.12. This also gives us a midpoint coil temperature of 78.57. So R401B is definitely a zeotrope mixture and has a very large glide of 4.12. So looking at R454B again on our refrigerant slider, we notice that our dew point and our bubble point at 350 psig is 113.1 on our dew point and 110.9 on our bubble point. So in this video, we're trying to explain to you the glide of different refrigerants. And one of the other things that we're trying to accomplish is to establish that the R454B refrigerant, which is coming to the field in about a year or so, is not a zeotrope mixture. And like R410A that you're familiar with, you can top it off and you don't have to worry about different boiling points. Because as you'll notice as we've been talking here about the slider and the temperatures, that on the condenser side also, we have an entering dew point at 350 pounds of 113.1, and we have an exiting bubble point of 110.9. When we subtract the two and divide, we get a 1.1 glide, which, as you will note, is a very small glide of the refrigerant. So we hope that you understand the bubble and dew point and the glide, and also understand that the R454B refrigerant that's coming soon has a very small glide, and even though the pressure temperature charts may show a bubble point and a dew point, they're so close together with a 1.1 glide ratio that it's not going to make a difference in your charging and checking the system for the refrigerant side.
Go to Airefco.com for more videos. Like, subscribe, and check back every week for new videos.